Hi engineering Janta, I am Vaibhav Shukla and today we will be studying a few more concepts in statistics. So go ahead and tell me that I am visible or audible to you. Am I visible and audible? Go ahead, tell me in the chat section. In the chat section, you can type yes if I am visible to you and audible to you. Go ahead, type it out. फटाफट टाइप करो यार. Great. So thank you. I guess I am visible and audible. So let's go ahead. Let's begin with today's topics. And today's topic is covariance. Fine. So there are two terms which are often used together. Fine. Which is covariance and correlation. Today we will be studying these two topics. Fine. Out of these two we will be studying covariance primarily, and in the next class we will be studying correlation. Fine. So what is covariance exactly? Fine. What is covariance? First of all, why these two are used? So covariance and correlation primarily tell you how two variables relate. So hi, good evening everybody, good evening youth, good evening Vibhuti. How are you? I'm not very good right now, my health is not at the peak condition, but yes, very soon I'll be fit. And Vaddi Chandra, hi, and to all of you, focus here. Fine. So covariance and correlation, what's the basic use of them? For two variables, how they are related, that's basically checked using these two measures. These are two measures to actually quantify how two variables are related to each other. Fine. And this covariance actually tells you how two random variables, fine, how two random variables change with respect to each other. Fine. So this WRT is with respect to. Fine. So with respect to each other, how do they change? That is basically covariance, and covariance quantifies that. I'll tell you how it quantifies, but right now focus here. For example, there are two variables x and y that you have at your disposal. Fine. Say that you have these numbers written here 3, 5, 7, 9, and here you have 14, 15, 16, 17. So if you carefully see, for every value of x, when I increase the value of x, the value of y is increasing, right? So x and y are positively correlated. What if I wrote one more data here, which is I wrote 2 and I wrote here 11. Fine. So in this case, when I decreased the value of x, the value of y also decreased. So they are positively correlated. When x is increasing, y is also increasing. When x is decreasing, y is also decreasing. Is that clear? This is positive correlation, or when we have such condition, we call it positive correlated variables. Fine. So these are positively correlated. Whenever x is increasing, y is increasing. Whenever x is decreasing, y is decreasing. Is this much clear to everybody? Good evening. Thank you so much. But fatapat batao, is this much clear? Say yes or no if this is clear. Fine. And then we'll move forward to the negative correlations. Pardon, this is not correlated, this is positive covariance. Fine. This is positive covariance, not positive correlation. Fine. This is positive covariance. And negative covariance. When do you have a negative covariance? Let's again take a data set where I have these values. 4, 5, and here you have 15, 14, and when you have 3, then you have 17, and then you have 7, then you have 9. So basically, if you see here in this data set, whenever the value of x is increasing, the value of y is decreasing. Whenever the value of x is decreasing, the value of y is increasing. Basically, what am I saying? When x increases, y decreases. When x decreases, y increases. See, when x was increasing 4 to 5, it increased, whereas y decreased. Wherever I increased the value of x, y, whenever I decreased, the value of x, y decreased. Whenever I increased it, y decreased. When x increases, y decreases. Whenever x decreases, y increases. So this is negative covariance. इसे negative covariance बोलते हैं. Fine. Now, when you want to find out covariance between two variables and you want to quantify it between x and y, how do you do that? How do you do that? Very simple formula, and when I'll show you that formula, now you will say, we have seen this formula somewhere. See, 1 upon n minus 1, fine, I equals to 1, n, and x minus xi minus sample mean of x, yi minus sample mean of y. Fine. So that is primarily the formula for covariance. Now, have you seen some formula like this somewhere? I'll show you where you have seen. See, if I try to find out covariance of x with respect to x only, then in this case, this would look like this, isn't it? To n xi minus sample mean of x, again xi minus sample mean of x. If I go further, this would look like this, equal to 1 to xi minus x bar ka whole square, isn't it? This would look like this. What is this formula? This is nothing but variance of x, right? Variance of x is actually the same formula, isn't it? So basically, when you covariate any variable with itself, then it gives the variance of it. Fine. Now this is primarily the covariance formula, and I'll also tell you the applications where it is actually applied. Fine, let's talk a bit about them. I hope this much portion is clear. Is this much portion clear? First of all, tell me in the chat section. If this much is clear, then I'll move forward. If you have any doubt, you can go ahead and ask. फटाफट बताओ, अगर कोई डाउट है, ask me out. If you are not having any doubt, then we can move forward. Fine. Is everything clear so far? Great. Great. Let's move forward. Now, I'll go ahead. I'll take a realistic application of it. Fine. Let's take a realistic application. For example, let's take a data set where size of house is given. Fine. What do you think? Size of house and price of house. How should they covariate? They should have a positive covariance, isn't it? As the size of house increases, the price of house should also increase. Common sense. So the covariance would be positive. But when we calculate the covariance, it should also come out to be positive. Let's check it. Fine. So let's say that this is in lakhs. Fine. This is in lakhs. And size of house, say for 1000 square feet. Fine. And rather I'll make the calculations simpler for you. So here I will write per 1000 square feet. Fine. Per 1000 square feet. Fine. So here it will be 1, 2. So this is basically 1000 square feet, 2000 square feet, 3000 square feet, and 4000 square feet. Price of the house in lakhs. Fine. So for 1000 square feet it is say 10 lakh, for 2000 it is 20 lakh, for 3000 it is 30 lakh, and for 4000 square feet it is 40 lakhs. Fine. This is the basic data set that we are having. Now if I try calculating the mean of it, the sample mean of it, what would it be? Fine. So 40 plus 30, 70, and 30, 100, and 100 out of 4, so 25 is here. I should write x bar, pardon, this is y. Fine. So let's treat it as y, this as x. So I would suggest writing this as y bar. Fine. So y bar equals to 25, and here x bar, what can it be? 4 plus 3, 7, 2, 9, and 10, 10 out of 4. So this is 2.5. Fine. So this becomes 2.5. Now in this case, rather, does it become 2.5? Yes, it does. Fine. So 2.5 is the sample mean of the size of house. Fine. So this is not just 2.5, actually this is 2500 square feet, because you have to multiply with this now. So this is 2500 square feet only. Think it in those terms, but we have used it for simplification of calculations. Now let's move forward and let's try calculating xi minus x bar and yi minus y bar. Fine. When I do this, what would it be? So this is 1. Fine. 1 minus 2.5 is minus 1.5. Fine. Then 2 minus 2.5 is minus 0.5. 3 minus 2.5 is 1.5, 4 minus 3 minus 2.5 is 0.5. Fine. So this becomes 0.5, and 4 minus 2.5 becomes 1.5. When I talk about this particular portion, what would it look like? Let's check. So 10 minus 25, if you see, what would it be? So this would something look like this, minus 15. Fine. Then minus 5, then what? It would look like 5 and 15. So basically this will somewhere cancel out. Fine. We have taken such inputs that they are cancelling out. What should we do? Can we do something? Yes, we can do something. Rather, to make this work for you people, what I can do is we can take some other input here and mean would change accordingly. Fine. And here also I'll take some other mean so that we have different values written here. Otherwise it will be very, very easy. Fine. 50 here, and let's do 5 here. Fine. So if I do that, what would it become? 5, 3, 8, 11. 11 divided by 4. How does that look? Again, I need a calculator like engineers. Fine. 11 divided by 4, so 2.75. Again, we'll have to change everything, because that would make everything 0. See, if I do the summation of all these, it would become 0. Whole point would fail of understanding. So let's take some better example where we can help us out. So 50 plus 30 is 80 and 110. So this becomes 110 divided by 4, and that's 27.5. Fine. So let's do some better calculations. I hope this time we would have something to calculate so that I can show you how positive covariance looks like. Fine. So let's do the hard maths again, and 1 minus 2.75 looks like minus 1.75. Fine. Then when I subtract 2 from it, minus 0.75. Then if I subtract 3 from it, then 3 minus 2.75 is 0.25. Fine. And then 5 minus 2.75 becomes 2.5. 0.25. Fine. So finally, I don't see them cancelling out. I am very happy. Oh my god, I cannot tell you how happy I am right now. Now, subtracting this 27.5 from every input, so 17.5, then minus 17.5 rather, then 20 minus 27.5 is minus 7.5, then proper 17.5 in positive sense, and then having 50 minus 27.5 gives me 22.5. Fine. So that is what we are generally getting here. Fine. That's not a bad distribution to see. And let's check how this would look like when we add them all. Fine. So 0.75, then adding 0.25, and then 2.25. So again, this is adding out to be strangely. Fine. Wait a minute. Is it correct? This is coming out to be 2.5 and 2.25, and this would again turn out to be 0, and this would also turn out to be 0. So all you can see is nothing but, even if I change a few inputs here and there, a few inputs would look like as it is, and basically what we are trying to get here is this would become, let's go ahead and calculate the covariance of x comma y, and then we'll take some better example where we can take some random values which do not cancel out. So this would become 1 upon n minus 1, fine, 1 to n xi minus x bar into yi minus y bar, and this becomes nothing but 1 upon n minus 1 is 3 into, both are 0 if you carefully see, so this becomes 0, and this is a positive covariance only. Fine, this is a positive covariance only. Why am I saying so? Because if you see carefully, for every increased size, the value of house is increasing. Fine. Now let's take some other example where we can actually try and get some positive value. Fine. Let's say number of hours studied. Fine. Number of hours studied, and let's see, let's keep it x, and marks that a person got. Fine. So if he studied 3 hours, somebody, he got 42 marks. Somebody who studied 4 hours, he got 51 marks. And deliberately I am writing these odd numbers so that we should get some actual positive output. Then if somebody studied for 5 hours, he got 60 marks, and somebody who studied for 8 hours got, say, 90 marks. Fine. Now when I try calculating the averages, how do they look? Let's see. Fine. So here I'll try calculating this, 3 plus 4 plus 5 plus 8. Fine. So this is nothing but 20, and 20 divided by 4 is nothing but 5. Fine. So I hope this looks good. Yes, it does. Fine. So this sum turns out to be as 20, and the sample mean comes out to be as 5. Here the sample mean is 42 plus 51 plus 60 plus 90. So this is 243 divided by 4. Fine. And this is nothing but 60.75. Now let's try calculating x minus x bar, xi minus x bar, and yi minus y bar, which is sample mean. So if I try calculating this, so 3 minus 5 is minus 2. Fine. 4 minus 1 is minus 1. 4 minus 5. Fine. 5 minus 5 is 0. And 8 minus 5 is 3. Fine. Now if you carefully see, again strangely for the second time we got 0 in our one of the inputs. Fine. So are they variating? Are they somewhere variating? Because we tried every possible thing and still we got 0. Are we variating? Again, this is a coincidence, let me tell you. There are data sets where such possibilities exist, that you can think of such possibilities where you will have better means and still they won't cancel out. Fine, you will have such data sets. Let me tell you, they are actually linearly varying from each other, and that's why you might think like this. However, this is again a pure coincidence. Fine, consider that somewhere this particular portion, this sigma of xi minus x bar had not been 0. Consider some data set like that. Fine, here if you are thinking that every time you will get 0, you will not. This is strangely a very different kind of data set that we again took. Again, coincidentally, it came out to be as 0. Fine. So try finding out. This is a homework for you. Try finding out. Do you often get 0 in covariance when you have positive correlations, or do you never get anything else? Try finding out. What you have to do is, you have to find out that whether this 0 comes every time or this is just a pure coincidence that we have got. Fine. I've just given you a hint of answer. It might lead you somewhere. I'm saying that this can be a pure coincidence that it can be 0. But does this coincidence happen every time? That you have to check. Fine. And in the next class itself, I'll open this mystery up for you, whether this is happening every time or whether it is just here only. Fine. So I'll open that mystery up for you. Fine. Don't worry about that. But right now, all I can tell you is that is it coincidence, or it can always happen that you'll have 0 as your answer. That you have to check. Fine. Now, imagine that somewhere you didn't get both of these values as 0. Fine. Somewhere you didn't get them as 0. Fine. Here also let's check for this as well. Fine. And strangely, let's do some hard maths again. 42 minus 60.75. So this becomes minus 18.75. Fine. And then 51 minus 60.75. This becomes minus 9.75. Fine. And then you have 60 at your disposal, where you have minus 0.75. And then you have 90, where basically you will have 30.75. Fine. So yes, we are getting it right. 30.75, rest is fine. So let's check how it is behaving. 18.75, and this should give you a very fine idea of this. Fine. So this is coming out as minus 1.5. Fine. This is coming out as minus 1.5. So all of you, for you, this particular value, this sigma here has been attained minus 1.5. Now interestingly, it is up to you who has to go home and check whether this can become any value of other than 0 or not, or will it remain 0 always. Fine. However, I have given you the answer, but go ahead and check it whether it is a coincidence or it can be always 0. Fine. So here consider that there are two values of these two inputs that we are trying to give which are non-zero. Fine. In that case, what would happen is your value would relate, say for some data set, this value is 25 and this value is 30. Fine. So it would be 25 into 30 upon 1 upon n minus 1, say here n is 10 only. Fine. So this would look like 75. Fine. This says if it is plus 75, then a positive correlation. If had it been minus 30, it would have been minus 75 and a negative correlation. Remember one thing, the important thing here to look out for is that whenever you are trying to find out any correlation and covariance, whenever you are trying to find out covariance, you have to understand that these values, whatever sign they are carrying, it is very, very important. Number one. Number two, if you have such positive covariance, what does it mean? Both the values increase with respect to each other, and when one decreases, the other also decreases. Fine. So this thing should be very, very clear to you. What are the advantages of covariance? One is you can quantify it. Fine. You can see the spread of data, how it is variating. And the disadvantage of it is, here you got plus 75. For some x and y, you can have 350. Plus 350 also can exist for some x and y. If these values are existing as covariance, in this case, what would happen is, which is strong? Somebody would say 350, but reality is not this. 350 is not stronger than 75, let me tell you. Fine, it is not stronger than 75. They can never be compared which is stronger, because you do not have any limit. You do not have any limit of covariance. Covariance can range from minus infinity to plus infinity. That's the problem. Fine. Covariance can range from any value to any value. And if that happens, we'll be in serious trouble. We cannot afford this. Fine. So in this case, I would always suggest that when we are having covariance, we can never say which is stronger or which variables relation together is not strong. For that, you need something called as correlation. Correlation has limits. Their correlation comes in play. Fine. So in tomorrow's class, we'll understand what exactly correlation is. कल समझेंगे, detail में समझेंगे. I hope this much is clear for you. However, find this out whether this is a coincidence or not. Fine. Tomorrow I'll clear this out, that whether this is a coincidence or not. Go ahead and keep making notes, keep working hard. If you have any doubts, put them in the chat section. If you don't have any doubts, we can wrap this up. Fine. So I hope everything is clear to everybody, because I can see no doubts, and that's great for a teacher when people are understanding. But for a very long term, if there are no doubts, then there is a serious question mark that whether you are studying or not. However, it is great that you're not having any doubts today. So we can wrap this up. I hope it's clear to you. As I always say, keep doing good for others. Good will always come back to you. Fine. So have a wonderful day ahead. With that note, bye bye. Take good care of